Hello everyone, welcome to CivilPrep. I'm Krishna Gupta. So here we are into the case study at the rate 1000. Okay, so this is also with respect to 3D models. Okay, as we have seen in the previous session that we have taken certain models, okay, and we were working on those models and how we can make our course more interactive, more fun, okay, with respect to study of this particular program. Okay, so starting with this part, I would like to ask you, please write in the comment box that how did you like the video, what were good things, what on what aspect there can be improvement. So there is certain general aspects here. Okay, now what we can see here that we have seen certain topics from geomorphology. Today I'll be covering certain topics from climatology part. Okay, so this is the one second important topic from geography optional, that is climatology. So starting with the topic here, I'll be starting with atmospheric circulation. So looking at this part here, we can see this is one of the important part that we can see here, the earth, the rotation of earth, which is from west to east. Okay, now here we can see that we have the presence of westerlies, we have the presence of north easterly traders, then we have north easterly traders. Okay, this is easterly winds, then here we have westerlies. Okay, when I just try to make this part here, we'll be seeing that here also we have the presence of easterlies, which are called as polar easterlies. Okay, and there is another polar easterlies in this part. Okay, so this is one of the model which specifies us, which explains us that how there is a trimeridional circulation is taking place. Okay, now here we can see that we have the presence of Hadley cell, this is Ferrel cell, and this one is polar cell. Now here we can see that how the earth rotates. Okay, how the rotation of earth is taking place, and how we can see the movement of wind is taking place here, and the changes in this wind is taking place because of the presence of this high pressure system. Okay, at the equatorial part we have low pressure system, at the polar regions we again have low pressure system. Okay, so this results us into the formation of the high pressure, low pressure, and high pressure system. So here we see that the winds, they always move from a high pressure system to the low pressure system, and again from high to low. So this is the general pattern of the movement of winds here. Okay, from high to low, the movement of wind is taking place, and they are basically deflected by the Coriolis force. Okay, so this is one important part where we see that we have the presence of the moment of wind, and which defines our atmospheric circulation. Now, in this part, we will see that there is two winds which is flowing in this region. The wind which is, as we can see this Hadley cell, we have one part of wind which is present at the lower end. So this is trade wind, and the wind which is present at the upper end, this is called as anti-trade wind. Okay, so here we'll be seeing that there is a component of meridional plus zonal circulation. Okay, so when the winds here, we see that they are moving towards upper part here, they are looking at the moment of the zonal part, but as they try to turn here, as they try to turn here, we see that there is uh, the meridional component is sorry, this is the meridional component, and this is the zonal component which is added here. So because of this, we see that the wind's movement and the system, the complete system, it is becoming more the meridional and zonal in nature. So there are both the components which are specified here. Now, we will see here that in the contemporary time, what is happening here? We can see this is headley cell, this is ferrule cell, and this is polar cell. Okay, so here we see that because of the change in climate, the headley cell here it is getting expanded. Okay, and in the second part, we'll be seeing that the ferrule cell it is also getting a bit expanded, because of which the polar cell here this is getting quite shrinked up. Okay, so because of this, what we are seeing that the overall length of the headley cell which is present here it is increasing, while the ferrule cell it is also diminishing, and the polar cell it is the one which is highly diminished. Because of this condition, we see that the wind in the headley cell, ferrule cell, and polar cell, here the winds they are getting slower. The wind speed, okay, in the ferrule cell it is quite consistent, but in the polar cell it is getting more faster. Okay, so these are the three different conditions which we can see here, which is dependent on the wind speed. Because it is getting slow, here the component of we can say the rainfall it is changing, and when the winds are slow, they are able to carry moisture for less distance. Okay, the moisture is carried for less distance, therefore we see that there is concentration of rainfall is taking place in the headley cell, therefore the weather is becoming more extreme here in the headley cell. Okay, in the ferrule cell it is quite consistent, but in the polar cell we'll be seeing that the winds which used to move to a certain distance, now because they are faster in nature they are moving more further than the previous distances. So because of this, what we are seeing that the rainfall pattern here it is again changing. Okay, the rainfall pattern is changing, and because of this change in the rainfall pattern, there is extremities here also is taking place. Okay, again extremities is taking place here, which is actually impacting the overall circulation system of the earth. Now, when we try to understand overall these conditions here, we will see that the there are certain models and theories which we can apply here. For example, there is Brewer Dobson, okay, circulation, which is basically driven by the Rossby waves, okay, which is affecting ozone and moisture distribution. Now, in the second part, we can also see here that there is Lorentz energy cycle. Okay, which is basically linked with the heat transport. Now, third part we can see here there is also a component of Coriolis force and geostrophic winds. Okay, now this is the first part we are seeing here, which is quite important. from the overall perspective of the atmospheric circulation, which is helping us to understand the movement of the winds, the expansion of the Hadley cell, and the contraction of the polar cell and the Ferrel cell. Okay, so this is the first model which we can understand here. So this is atmospheric circulation. Okay, this is the Earth, and here we can see the overall Earth and how these winds they are moving here. Now, moving to the next part. The next topic here we have, that is the hydrological cycle. Okay, under the hydrological cycle, there are few important parts. For example, number one, we have sun. Okay, sun, it is providing us insolation. Okay, because of insolation, the water, it is getting up the latent heat of evaporation. Okay, because of the latent heat of evaporation, they are becoming moisture. This moisture, it is moving up and it is becoming cloud. Okay, here we can apply Birkin's process. Okay, we can understand this from the Birkin's process. He has provided us the ice crystal theory. Okay, the ice crystal theory, which is helping us to understand the formation of precipitation. Okay, here we can see that the rainfall is taking place at one place, and at the another place there is a snowfall is taking place. So here we have rainfall. Why rainfall is taking place here? Because the condensation which is taking place here, this is taking place below freezing point. While in this part, we are seeing that we have snowfall, and this snowfall, it is taking place because it is here the clouds, they are moving uh, beyond the freezing point. So it is above freezing point. Now, because of these two conditions, what we will see here, that there is formation of river is taking place because of rainfall, and because of snowfall there is formation of glaciers, and both of them, they are contributing for the formation of the groundwater system. So here the water, it is moving towards the sea again, and the groundwater, it is also connected to the sea. So because of this, what we see, that there is a cycle is been going on from land to sea to atmosphere and again to land. Okay, so this is hydrological cycle which we are seeing in the contemporary time. Now, what has happened in the recent context? We'll be discussing this part, that what has happened in contemporary time. So here we are seeing that the tropospheric moisture, it is increasing almost at 7 degrees Celsius per 1 degree Celsius rise in temperature. Okay, this is one of the case, or this is one of the model which is provided by Clausius Clapeyron. Okay, who is providing this contemporary aspect with respect to water cycle. Okay, so because of this, what we can see here, we can analyze one thing, that number one, The precipitation here, it is increasing. Number two, the evaporation. This is happening because of evaporation, which is also increasing. But in the third part, what we are seeing that because the water over land, it is also increasing, but it is resulting more into surface runoff. It is increasing, while at the same time, there is decline in groundwater. The groundwater, it is declining. So here we'll be seeing that previously, this was the overall precipitation, and this was the overall water which is going into the groundwater system. This is groundwater. But currently what we are seeing that the precipitation, it is increasing. Okay. While we are seeing that the water which is going to the groundwater, it is declining. And previously we were seeing that the surface runoff, it was quite lower. But in the contemporary time, we are seeing that the surface runoff, it is increasing. So this is surface runoff. So we are seeing here that there is certain issues with respect to the groundwater system, which is happening because of the hydrological cycle, and overall this condition is taking place because of global warming. Okay. Now, to understand this more, we can apply here the general circulation model with the hydrological models here. We can also apply the evapotranspiration dynamics, which is basically also provided in the Trevartas model. Then we can provide here the energy with respect to the conservation of energy in the form of latent heat. For example, latent heat of evaporation, latent rate of condensation, which we are seeing here. Then perspective from the human side, we can see here that there is needed to be better planning for water resources, which requires a technocentric approach. Plus, it also provides us a point of limits to growth. Okay. Then there is a aspect of climate change which can be added here. Okay. So this is quite important for us. Okay. Now there is one of the data is provided here that up to 21% increase in the temperature here, which is related to the rainfall, and this has happened because of almost 2 degrees Celsius rise in temperature. Okay. So this is provided by PHRAMM model. So you can also add this part that which model is providing this data. So this PHRAMM, this is the model which has provided this data here. Okay. Now moving to the next part, moving to the next topic. So next topic that we have here, that is hurricane. Okay. If we look at the hurricanes is one of the we can say one of the it is a storm, or we can also classify it under atmospheric disturbances. Okay, under the atmospheric disturbances, these are classified under tropical cyclones. Okay, these tropical cyclones, they are part of hurricane. Now, when we look at this part here, the hurricanes in the contemporary aspect, this is a hurricane. Okay, we can see here this hurricane, they are basically formed because of the low pressure system over the sea region. Now, this model, it is providing us that how hurricane is formed here. But to view it better, we have another model here. So we can say this is one of the region of North America. and this is Pacific Ocean, and this is one of the hurricane here. Okay, we'll see that almost every year there are the various hurricanes are formed here. Okay, now if we look at the formation of hurricanes, if you look at the formation of hurricanes, the hurricanes they are getting intensified. Hurricanes are getting intensified in the contemporary times, which is resulting into the devastation in the recent times. Okay, for example, the recent hurricane which occurred, it is called as Hurricane Milton, which occurred in 2024. Okay, so this was one of the quite devastating event or devastating hurricane, because tropical cyclone will be seeing that these tropical cyclones they are very disturbing. Okay, they are causing higher damage. And why this is happening? What is the reason? Number one, there is sea surface temperature rise, which has already taken place more than 2 degrees Celsius. And this 2 degrees Celsius, as we have seen in the previous part, we can also apply it to this area, that is PHRA-MM. Okay, this is also provided by IPCC. Okay, IPCC report, they have also given that 2 degrees Celsius has been breached in the year of 2025. Okay, apart from this, if we want to understand a few more hurricanes, there is Beryl. Okay, this Beryl hurricane, it is also an important hurricane. Okay, which was seen in the region of United States of America. Okay, now uh, in today's aspect, we are seeing that the Northern America, it has been warned of another hurricane, which is forecasted to be coming in next 4 to 5 days. Okay, so the region will be preparing for the coming of the next hurricane here. Now, when we look at this part here, we will see that according to certain data, so there is almost 4 to 9% rise in inner core. Inner core, when I'm talking about the inner core, so this is one of the hurricanes we will see here. So this is the eye of the hurricane. Okay, this is the inner band, and this one part is the outer band. This is the outer band part here. So we can see here that this is a calm region. Okay, and here we see that there is maximum clouds, and these clouds they are of cumulonimbus. When I just uh, when I just rotate this model, here we can see that this region, it is almost touching the troposphere, because whatever the clouds are formed near the eye region, they are reaching the troposphere also. Okay, so this is the rain band. Okay, we can see this is the eye region. Okay, this is the inner band, and this is the outer band. So this is the one of the cyclone which we can see, which is hitting the North America region. Okay, now here we see that the inner core, it is getting more intensified because of the climate change, which is providing a 4 to 9% rise in the inner core rainfall in this particular area. Okay, now talking about models, we have already seen one of them, that is the PHRA-MM. Then we have potential intensity theory. Then we have energy vorticity balance theory, which can also be substantiated here. Okay, so this is the hurricane topic, which is quite important. So this is resulting into various other aspects with respect to damage of life, damage of property, agricultural losses, then overall there is disturbances of supply chain management and the economic condition it is getting affected. Okay, so this is hurricane. Now next topic here we have, that is the ozone hole. Now I have given this question also with respect to ozone hole. Okay, now this I got a video on this part, so you can just watch this video. Okay, so here you can see that I'm just stopping it. So here you can see that this is the Antarctica region. This is the Antarctica region, that is the South Pole. Second thing we'll be seeing here, that this polar vortex, okay, this is the region what we are seeing here. This is polar vortex. This polar vortex, they become very strong during the winter season. Okay, during winter season, for example in the contemporary time, for example we are under June now. So June is summer for us, but at the southern hemisphere it is winter season. Okay, so during winter season it becomes very strong. But what we see here, that as the winter season it starts to transition towards the summer. Okay, during summer, so during winter part, what happens here, there is intense formation of high pressure system. This high pressure system, it actually stops the intermixing of air or wind. I'll be writing here wind, it is a better word. Okay, winds between two regions, that is polar region and temperate region. So these two winds, they are actually separated here because of the formation of high pressure system. So because of which the region it becomes very cold. The temperature almost it goes to minus 60 degrees Celsius during this time period in the air part. But what happens at the same time? This results into the formation of stratospheric cloud. Stratospheric clouds, they are actually consisting of CFCs, HFCs, HCFCs, along with this chlorine, bromine, etc. So when they are present in the clouds, and as the summer is approached, so these clouds they are present in the crystal form. But as the summer is approaching, the temperature rises. Because of the rise in temperature, all these components which are this resulting into the ozone hole component. These are the ozone hole component. They actually starts eating up the ozone, and this results into the drastic decline in the ozone. So this results into the formation of ozone hole. So here we can see the dates here. Okay, we can see date here. I'm playing it again. Okay, so here we can see this is starting from almost July, August. Okay, August it is winter. Now, as August is passing, September, so here the ozone is getting intensified. Why? Because the summer is approaching there. So during the summer season, the uh, this particular hole it is getting very highly intensified. Now, during the winter season, as it comes back, the holes become normal, and it becomes again back to normal conditions. Okay, so this is one of the condition which we can see here. Just give me a second. So this is one of the condition which we can see here that is happening with respect to ozone hole. Now, when we talk about ozone hole, when we talk about ozone hole, there are few things which are quite important for us to understand with respect to ozone. Now, number one, what we are seeing here, that is the ozone hole. It is very highly given under the Brewer Dobson model. Okay, Dobson is also one of the unit under which the ozone is measured. So this Dobson, it is one of the units also. Second thing, what we need to remember, that is Chapman series of reaction, where under the ultraviolet rays, okay, there is continuous formation of ozone hole, ozone, and there is continuous destruction of ozone into oxygen and oxygen radical. So there is a continuous formation of both this ozone and construction, the formation of ozone and destruction of ozone is taking place simultaneously. Okay, so this is one part which is quite important. Now, third thing, what log we can apply here, that is the photochemical equilibrium. Okay, now under the perspective part, what we can see here, we have Montreal Protocol. Then next we have Vienna Convention, which are working for the ozone hole depletion. Okay, now we are seeing here that in the contemporary time that there is changes in the stratosphere. This is happening because of stratospheric cooling. Now, stratospheric cooling, it is one of an important topic which I will be covering in the next class. Okay, what is stratospheric cooling? How it is taking place? What are its implications? Okay, so for understanding stratospheric cooling, we can connect in the next topic. Okay, so guys, this is one of the case study which is basically developed with the help of 3D models. So for more case studies, you can stick to the channel. You can join the channel. You can join the Telegram group. We are having discussions. Okay, apart from this, we are also having answer writing that is live. Okay, we are discussing answers in a live format. Okay, so you can also join that session. So join the group. Okay, subscribe, do share it with your friends. Okay, do comment that how did you find the sessions. Okay, so see you in the next session. All the best and thank you.